Hi, I'm Lindsay. In my previous video, I explained how pairedend sequencing works, and now I'm going to give you 6 reasons why pairedend sequencing could be better for your experiments. It's safe to say that the longer the run, the more expensive it's going to be. In the past, pairedend runs were more expensive than single-end runs, even with the same number of cycles in total, but that's usually not the case anymore. But the longer run is still going to be more expensive. But then, what makes pairedend sequencing the better choice for many experiments? It's because of the massive improvement in mapping of the reads. Because if you think about it, a pairedend run of 50 cycles will sequence exactly as many nucleotides as a single-end run of 100 cycles. So then why is it better? Look at this example. If there are highly similar sequences on different chromosomes and you have one single read, this can't be confidently aligned. However, if you have a pairedend read, the aligner will know that both reads belong to the same chromosome and the mapping will be correct. The same is true for repeat sequences. And keep in mind that you roughly know the insert size because that depends on the type of library prep. Now another benefit, if you analyze RNA, is that pairedend reads can tell you more about intron spanning, and that's information you won't have if you do a single-end run. And if you're doing de novo sequencing without reference genome, it's obvious that having pairedend reads will help you more to solve the puzzle. Also, if you're looking at low-level mutants, read errors can create problems. If you have only one single run, you don't know if the mismatch is a real variation or not. But if both reads show the same mismatch, chances are much higher it is true. And finally, and I think that this is often forgotten, if you're interested in coverage, doing a pairedend run will give you much more information, as you can fill in the gaps during the analysis. And I think this example clearly shows that with the same number of sequenced nucleotides, there is much more coverage information. Does that mean you should never do a single-end run? No. If you are only sequencing very short RNA fragments, for example small RNA, ChIP-seq or CLIP-seq or anything like that, a short single-end run will usually be sufficient. But in most other cases, pairedend runs are better. So, unless you know for sure that it is okay for your experiment to go for a single-end run, it's usually better to choose a pairedend run. I hope you enjoyed this video. If you want to see more, please like and subscribe, and if you have questions or ideas for new videos, put it in the comments below.